Hi, welcome. Page 250, number 12 is 60 degrees. 14, measure of angle 1 is 37.5 degrees. Measure of angle 2 is 37.5 degrees. The measure of angle 3 is 133 degrees. Number 16A is isosceles and obtuse. Number 16B is 3.5 degrees, I think. Yeah, maybe, angle, yes, great. 18 is 65 degrees, 20 is 33 degrees, 22 is 31 degrees, 24 is 62 degrees, 26 is 26 degrees, and 28 is 55 degrees. That's as far as we went, or did we do some of these other guys?
Nope, this is it.
That's it. We didn't do any proofs, that's all right. It's coming.
We should practice them.
Well, yeah, when we, get there. Okay, what questions do we have on this lesson? I can do 16. She's got up. Look at her. Go. Good job. Very proud. 16. The path of the airplane can be modeled using two sides of the triangle as shown. The distance covered during the plane's ascent is equal to the distance covered during its descent, which is not always true, but in our little idealized math world, it is true. Okay, so classify the model using sides and angles. So we've got this big old triangle. 173, is that right? 173 degrees. All right, so what kind of triangle is this?
Isosceles.
It's isosceles. What tells us that?
It has two sides that are congruent.
Yeah, these Dick Mark say that these are congruent, so it's isosceles, which is defining the triangle in terms of its sides. What kind of triangle is it in terms of its angles? Obtuse. Because it has bigger than 90-degree angle, right? It's isosceles and obtuse. Now for part B, the angles of ascent and descent are congruent. Find their measures. So this is congruent to this, so we need to figure out what that is. So what piece of information can we use to figure that out?
Well, all three of them added up equal 180.
All three of them added up equal 180. So 173 plus 2 times our angle in question equals 180. So how do we solve that little dude?
2x equals 7.
Yeah, and how'd you get there?
I moved this 173.
Yeah. Subtract the 173 and insert 2A for angle. Why not? Probably should be like a lowercase a, but whatever. Equals 7. And now what?
Divide both sides by 2.
Divide both sides by 2. And we get A equals 3.5 degrees. The real shallow taking off, right? I think often the big old planes have a steeper angle of ascent. Yeah. They may start out at that. They may just start out at that and then they go, their path aren't quite as linear as what's on the thing, but that's fine. Maybe. I bet the average would still be a bigger degree measure, but
You gotta go really far to get off the ground.
yeah.
Yeah, and they go like, even when you're sitting in one, you can kind of see that it's tilted up more than just.
Well, the tilt that's because of the wings. The tilt and the ascent don't necessarily match. Because physics is cool. I like physics. Physics is very fun. What other questions do we have from this lesson?
Can we do 20?
Sure, I'd be happy to do 20.
What's the reason of water?
You know, you ask that like every other class day.
Well, because I think it's funny.
It's a funny thing to ask.
Yeah.
What's the meaning of what?
What's the meaning of life?
The meaning of life is
Or do you know?
objective depending on who you are and depending on what God has for you. So
Did you say objective?
I don't know what the right word is.
Subjective.
You meant to say subject.
Yes, it's
And
subjective
that's-
to that. Now,
I don't think even that is the word you really meant, but that's fine.
I was like,
The meaning, what he's trying to say is the meaning of Jacob's life is different than the meaning of your life. That's what he's trying to say. Okay, so we're supposed to find the measure of angle 4. What are we going to use to get there?
I really feel like the.
No, stop, back. Is it this problem? No. Okay.
Yes, it is.
Oh, okay, what? Go ahead.
You just okay. I feel like in these problems, like with the measure 4, they should start putting the angle symbol there because it confuses my. Like I know they have a thing in front of the 120 or after the 123, but I feel like they just need to start putting the angle symbol.
Like this? Is that what you're saying?
Yes, because I did the whole problem and then I erased it because I used 4 as a number.
Ah.
so
Well, the question literally says the measure of angle 4, like on the top of 20, like, so.
Wait, but it could be any of the angles.
No, how could it be any?
Marked on page 1.
I don't understand. Anyway, let's back to my question. How can we get there? What tool are we going to use?
Yeah.
sum of opposite
Supplementary
angles.
and then,
Why don't we just use subtraction like 123 minus 9 equals 4?
Well, that's ultimately what's going to happen, right? But you were right to begin with, and then everybody said like 500 other words, right? The exterior angle theorem, right? It's what we're using, yeah? So 90 plus the measure of angle 4 equals 123, right? And then subtract. So yes, and then also yes. What?
Nothing.
Were you thinking to go a different way?
Yeah.
Yeah. You were gonna, instead of using that one theorem, you were gonna hop, skip, and a jump there? Yeah. It would have worked. You would have got the same answer, or you would have got the same answer.
The supplement theorem?
Yeah.
Yeah. So 123 minus 90 is 33 degrees. What other questions from this lesson do we have, kids? Oh. Nothing else? Nothing like the 22 or
22 was fun.
or any of the ones of 24 through 28?
This lesson was actually really great.
Nice. Did you like this lesson? Nice.
Triangles are fun.
Triangles are fun. This is probably my favorite lesson in this book.
Lesson or unit?
Lesson.
Oh.
Well, unit, maybe.
Okay.
Yeah. No, this is a fun unit. And very useful, IRL. I get to be cringe. You see these gray hairs? They're cringe. They're cringe. They're permission for cringe.
Actually, no.
Where's my permission?
You
What?
said Right.
What?
Who are you?
Huh?
What?
What?
Why are you? No.
Yeah, I don't know.
No other questions on this lesson, so y'all are ready for a quiz. If I were like, okay, we're gonna do a quiz, you're gonna ace it. You don't have any more clarity that you need.
What if we did
Is that what
have
y'all
a
are
question
telling me?
Okay, so
And we don't want to take the
what if they
Who's that?
Yeah.
What's so
Anytime
funny?
Anytime
You
anyone uses, I'm using superlatives, obviously, so what I'm saying is obviously not always true, but bear me out. Anytime anyone says they, the sentence is probably stupid. Because they is some nebulous nothing that they can't even define.
What if they use the word they to like refer to somebody?
Yeah,
Yeah.
that's what hence the disclaimer at the beginning of my paragraph. Yeah, if I was saying they are sitting in the corner, then, that's not a nebulous. It's just those ones sitting in the corner, right?
Yeah.
But then there's like they are secretly watching us or whatever, that's like,
Yeah.
not based on reality, it's based on whatever.
So if I use the word they, then I can sound extra stupid.
Probably.
That's
Okay, well, let's take a quiz then. I like this idea. Let's do it.
No, please.
No, please stop it.
Stop.
All right.
No.
Quiz 4-2. Page 250. Numbers 1 and 3. There we go. Okay, let's do a proof. Let's do page 253, number 43. Because y'all can use all the practice we can get on proofs, right? Right. We're gonna write a proof. We got a pentagon. But not the one that houses the military, just this one right here. Okay, that wasn't very funny. I agree.
What page is this again?
253.
I didn't even hear what you said.
I made a joke about this being a pentagon and the military industrial complex building also being the Pentagon. It was not a very funny joke, which is why no one laughed.
I thought that you said pentagram for a minute. I was like, whoa.
It doesn't have a T in it.
I was like, hold
It is not a pentagram. That is not what it is. It is a pentagon.
I had a friend who would draw a pentagram. She was creepy.
And then you got help and that alter ego went away.
What? What?
I made a multiple personality disorder joke. It was funny.
I see.
Okay.
Well, are you joking about people with multiple personalities?
No, joking about
You know, if I was, there's so few of them in existence anywhere in the world that, you know, what are they going to do? Get all of their self to come attack me? I don't think that's going to work out.
Oh my gosh! What the heck?
You know, it is still, despite what Hollywood would have you believe, it is still debated really whether that even actually exists. There's a lot of debate whether.
I'm pretty sure it
There's a
does.
lot of debate whether there's been any real case of multiple personality disorder. If there ever has been, it's exceptionally rare, which is why I get annoyed every time I see some reposted video that was on TikTok that's now on Instagram. Instagram's like, oh my gosh, here's my friend Brad, here he is. Child. If that exists at all, if it does, it is so rare that you are stupid right now. Stop it. You go find some other way.
But it is rare.
Find some other way to make friends. Because that's just stupid. All right, so we are supposed to prove that the measure of S. Prove that the measure of angle S plus the measure of angle STU plus the measure of TUV. We're proving a theorem that we're going to learn later.
If it's a pentagon, doesn't that already prove it?
We don't have access to that theorem yet. But yeah, once we do, yes. Yes, it does. Later in like a few chapters. Yes.
Okay.
Because the measure, the sum of interior angles theorem. So, yes. So that's what I just said. We're proving a theorem that we're going to learn later. Plus, just, jokes aside, to be fair, that's how those theorems end up becoming a thing, is because somebody sometime proved it, and then we can say it for all of them. So which is why that's a very common thing when we're learning about proofs, is to prove theorems that have been proven. In fact, that's pretty normal. Probably most of the problems in here are at least heavily related to some theorems that have already been proven somewhere else. 540 degrees. So you get to practice on the shoulders of giants. So we're trying to prove that this angle plus this angle plus this angle plus this angle plus this angle equals 540 degrees. That's what we're trying to prove, right? So what do we do?
Did you not just say that all three are triangles and 180 equals 180?
Great. Yeah, that's absolutely the direction we're going to go. So let's break that into some steps and go for that. Let's head there. So which one do you want to start with?
RST.
Sounds great. So we need to name all those angles. So what is this angle called?
Angle S.
And we can call it angle S because why? Why don't we need more letters?
Because if we called it RST, that'd be the triangle.
No, then that would be that if we put triangle. Because the other two angles, we can't just say the letter, right? But this one, we can just say angle S. Why is that allowed on this one?
Because it doesn't have.
Oh, it's not split.
Yeah, there's only one angle there, right? So we can just call it by its vertex. So angle S plus angle, what do we need to call this one? We can't just call that R, right? There's three angles at R.
TRS.
Yeah, TRS or SRT, either one, right? SRT plus, you should all say measure, right? Measure of angle STR equals 180, right? What lets us say that?
Sum of interior angles of a triangle.
Interior triangle angle sum. Seems reasonable. I could tell that gibberish if I was trying to grade, yeah? Now what?
Do the same for the other two.
Yeah, same thing for all the other ones. In fact, it's the same justification, and we're not relying on anything else up here, so we can put all these in the same step. So angle, the measure of angle RTU plus the measure of angle TRU plus the measure of angle RUT equals 180. And then the last one would be the measure of angle V. That one also just has one there, right? So that one we can just say by itself. Plus the measure of angle VRU. Plus the measure of angle RUV equals 180.
Can we just say that all those angles together equal 540 because of the sum of angle addition?
So here's the trick with angle addition postulate. How many different angles are involved in angle addition postulate? Two. We got like a bunch. 6, 9, right? Because this one's all split up. So we can't just do that, right? So what could we do? We can kind of do what you're saying.
So the measure of a triangle RST equals 180 plus the measure of triangle. RTU or whatever.
What does the measure of triangle whatever mean? What does that mean?
The measure of the angles of a triangle altogether plus the measures of
But do we
another
need to say that
triangle.
because all triangles always equal 180 degrees?
That's what we just said, right?
Yeah.
Right?
I got lost a long time ago.
We're just saying that the sum of all these angles equal 180, the sum of all these angles equal 180, and the sum of all these angles equal
Do we
180.
need to turn them
Okay.
into their values?
Well,
We can't.
So it has to be. Well, can we take it angle addition in 2 steps, saying 180 plus 180, and then adding
Yeah,
that
that's
way
what I
for
was
another
thinking,
180. So you're adding 2 triangles, and then you're adding another triangle.
Two triangles. Oh, yeah, I see what you're saying.
Yes, 2, and then in the next step, you take the one that you just.
You could.
That's how I was.
You could. We can even shorten it actually a little bit further.
How does it say to do it?
I'll show you. You ready? Measure, they shortcutted. And I will tell you this, like, I wouldn't give you a proof that was this long, probably on this test. You can add a line in here, like if you don't want to write all of this crap over and over and over again, like when you're having to do substitution, you can add a step that says let angle SRT be angle 1. And you can basically add numbers to all, you can add in numbers to all the things so that you can say angle 1 instead of angle SRT. If you want to save yourself writing later, that is a thing that you can do, which is kind of what they do in the book, but they don't even do that. They just are like, this is angle 1 now. And so they do some magic, but we're going to just do it this way. So plus the main measure of angle SRT plus a measure of angle STR plus the measure of angle RTU plus the measure of angle TRU plus the measure of angle RUT plus the measure of angle V plus the measure of angle VRU plus the measure of angle RUV equals 540 degrees. But the question is, why? In other words, what justification, right, can we say?
I gotta be honest.
Wait, so why doesn't it? Why can't we just
It's
do it like
just too
that and
much
say
for my
additional
brain.
stuff?
We can do that, not stuff, not stuff, but addition something,
We could give up.
addition property.
That's all we needed.
See it.
We
That's all we needed.
Yeah.
could.
Wow.
Okay.
Because 100, because this equals, so you could make a case, somebody could make a case for needing a substitution step in here, but since these are all equal to 180, then we just add them up and they equal 540. So you're kind of doing substitution and then addition, right?